I welcome all of you in International Year Conference on Chemistry Research and Competencies organized by IQAC and Department of Chemistry, Yeshwantrao Chavan, College of Science, Karad. Now I request Head Department of Chemistry, Yeshwantrao Chavan, College of Science, Karad, Dr. S.H. Gurumle to welcome all honorable chief guest speakers and all participants. Dr. S.H. Gurumle.
Okay, thank you, Mari sir. Good morning to all, dear honorable guest patron, organizing committee and valuable participants. On behalf of Board for Higher Education, Sri Shivaji Shikshan Samstha, Yeshwantrao Chavan College of Science, Karad, Internal Quality Assurance Cell and Department of Chemistry are organized international e-conference on chemistry research and competencies. On occasion of this function, I give us an immense pleasure to welcome all of you. In particular, I would like to express my gratitude and warm welcome to our plenary and featured national and international speakers. We would like to express our heartfelt gratefulness to the chairman of the Sri Shivaji Shikshan Samstha's Board for Higher Education, Karad, and Cabinet Minister of Maharashtra State, Honorable Sri Balasaheb Pandurang Patil, Honorable Sri Prakash Pandurang Patil Bapu Sir, General Secretary Board for Higher Education, Sri Shivaji Shikshan Samsthas, Karad, all the members of the Samsthas and respected Dr. B.L. Gopne Sir, Coordinator Competitive Examination Center, Karad, Honorable Principal Dr. S.B. Kengar Sir, today's Chief Guest, Honorable Professor Dr. P.S. Patil Sir, Head Department of Physics, Honorable Sushil Kumar Jadhav Sir, School of Science and Technology, Shivaji University, Kolhapur, and Professor Luciano Carlos, Scientist, Department of Chemistry, National University of Coimo, Argentina. Dr. Marcus Perlata, Department of Chemistry, National University of Coimo, Argentina, and committee members for making this conference is possible. To our eminent speakers and delegates who have come from all over the nation and world, we are indeed honored to have you here with us. We have about more than 600 participants from the countries and gathered here today, making our conferences truly international one. I have to confess that all are who really admire and have high respect for them to their contribution towards the field of research, and holding this conference is also an achievement itself. The organizing committee, principal, IQAC coordinator, and faculty of department have worked pandemic period to make their conference possible. The aim of conference is to achieve current research interest and to point out the possible future in chemistry. I feel honored to welcome all the participants and my fellow colleagues for taking a keen participation in this important program. Our entire speaker is very special, deep knowledge and quality of research. I hope that their knowledge is very useful and beneficial to all participants. You all feel enriched knowledge after completion of this event. Through this conference, we would like to engage with all of you in an open and constructive dialogue about the treatment of wastewater and how to write a best research paper. We hope that you all will have a great time ahead. Thank you all.
Thank you, Dr. Gurumi sir. Now I request Principal of our college, Dr. S.B. Kenga sir, to deliver welcome address.
Good morning all. My humble tribute to Honorable Sri Yeshwantrao Chavan Sahib, Honorable Sri P.D. Patil Sahib, and so Honorable Peditai Chavan. Again, good morning and welcome to all in one-day international e-conference on chemistry, research and competencies organized by Internal Quality Assurance Cell and Department of Chemistry, Yeshwantrao Chavan College of Science, Karad. I feel honored to welcome Honorable Balasaheb Patil, Minister of Cooperation and Marketing, Government of Maharashtra and Chairman of Sri Shivaji Education Society Karad, Board for Higher Education, Honorable Prakash Pandurang Patil Bapu, General Secretary Board for Higher Education, Sri Shivaji Education Society, Karad, Dr. B.N. Gopnil Sir, Coordinator YB Savan Competitive Examination Center and Office Bearers. A warm and hearty welcome to Honorable Dr. P.S. Patil Sir, IQAC Coordinator, former Dean, Faculty of Science and Technology, Head Department of Physics, Shivaji University, Kolhapur. Honorable Dr. Luciano Carlos, Scientist, Institute of Research and Development in Process, Engineering, Biotechnology and Alternative Energies, Neuquén, Argentina, and Assistant Professor, National University of Campus, Argentina. And the second speaker, Honorable Dr. Sushil Kumar Jadhav, Assistant Professor, School of Nanoscience and Technology, Shivaji University, Kolhapur, Maharashtra, India. College, Sri Shivaji Education Society, Karad Board for Higher Education, founded by Honorable Sri Yeshwantrao Chavan, former Deputy Prime Minister of India, established this college in June 1958 as a Science College Karad, with an objective of providing education in science to students of the Karad and surrounding area in Maharashtra. To keep his memory alive, the college was renamed after him in 1986. The college building, inaugurated in 1960 by the President of India, Honorable Dr. Rajendra Prasad, is located in a sprawling campus of around 40 acres and has flourished under the able stewardship of Honorable Sri P.D. Patil Sahib. Now the college is successfully run by Honorable Chairman Sri Balasaheb Patil, Cabinet Minister, Corporation and Marketing, Maharashtra State. Today, Yeshwantrao Chavan College of Science, Karad is one of the premier educational institutions in this region. The college is a granted aid institution affiliated to Shivaji University, Kolhapur. Our college is also an ISO 9001:2015 certified college and is now accredited to B++ level by NAC in 2017 in third cycle. The college offers total 13 courses at the graduation BSc level. The college has facility of postgraduate courses in microbiology, chemistry, and recently from 2020-21, the MSc Botany will be started in the college. The college has recognized research laboratory for PhD in microbiology, zoology, and botany. MPhil courses in botany and zoology are also being offered in this college. Three professional courses such as BSc in Biotechnology, BSc in Computer Science, and BSc in Computer Science entire at graduation level. From last year, college has started MCA course recognized by YCMOU Nasik. The college has also received several grants for the major and minor research projects and for infrastructural facilities from funding agencies like UGC, CPCP, and DSTSCRB. To achieve academic excellence, our meritorious students have consistently occupied to place in a board and university merit list. In this academic year, 2017-18, college has received award of maximum number of merit scholarships in urban areas as well as in a science stream by Shivaji University, Kolhapur. Along with it, the Sanstha has also started YB Savan Competitive Examination Coaching Center. The aim of to start this center to provide guidance to the students who come from rural backgrounds, to develop good administrators, to create awareness among the students for various competitive examinations. In short, our Sanstha has facility to educate students from KG to PhD. Wish you all very informative and insightful e-conference. on chemistry, research and competencies. Again, I welcome you all and thanks for attending this e-conference organized by Yeshwantrao Sawan College of Science, Karan. Thank you.
Thank you, sir. Now I humbly request General Secretary, Sri Shivaji Education Society, Board for Higher Education, Honorable Sri Prakash Pandurang Patil for Presidential Address.
Argentina. Respected speaker Dr. Sripal Jadhav, Assistant Professor, School of Nanoscience and Technology, Shivaji University, Kolhapur, Principal of College Dr. S.G. Kinga, and faculty members of Chemistry Department and other departments of Yeshwantrao Sawan College of Science, Karat. Dear participants, researchers, invitees, and students who have joined this international e-conference from different parts of the world, ladies and gentlemen. First of all, I congratulate and offer my thanks to Principal Dr. S.B. Kingar and his colleagues for their continuous academic touch with different stakeholders during this COVID-19 lockdown period. I am very much happy to let you know that even the college is locked due to COVID-19, the academic activities like webinar, e-seminar, e-learning, digital classrooms are continuously diffused to students, researchers, teaching faculties, as well as the parents through distance mode with different media's platforms are going on by this college. I am very much happy to let you know that the college has started the academic session effectively for this year through distance mode. I am very much happy to welcome Honorable Professor Dr. P.S. Patil, today's chief guest, and Honorable Speaker Dr. Luciano Carlos and Dr. Sir, at the same time, I welcome you all, participants and viewers, with the bottom of heart in this pleasant morning for joining this international e-conference. May I take this opportunity to introduce our Shivaji Education Society's Board for Higher Education, the multidimensional personality, former Defense Minister, Home Minister, Finance Minister, and Deputy Prime Minister of India, and architect of modern Maharashtra, Honorable Yeshwantrao Sawan, has founded this institute in 1958 to cater the needs of higher education of the society and the underprivileged. From the responsibility as an chairman of this institute till his last breath. At present, Honorable Babasaheb Patil, Minister for Cooperation, Government of Maharashtra, pure science faculty college named as Yeshwantrao Sawan College of Science, that is today's host college, and another one having arts and commerce faculties named as Venutai Chauhan College in 1971. Both the colleges are performing quality education and research along with cultural and sports activities in Western Maharashtra in general and in the jurisdiction of Shivaji University Kolhapur in particular. Yeshwantrao Sawan College of Science is first pure science college in Maharashtra state, founded in 1958. Now it has 13 special subjects at graduate level and 3 special subjects at postgraduate level. Our college is recognized for PhD laboratories and courses in microbiology, chemistry, botany, and zoology. The college is having B++ grade in the third cycle of NAAC Bengaluru. At the same time, I am very much proud to let you know that our college is first ISO certified college in Western Maharashtra. Coming to the topic of today's international e-conference entitled Chemistry, Research and Competencies, much concerned in regard to present worldwide epidemic disaster. Entire world is looking for to overcome this calamity. Scientists, researchers of medical and health sector, as well as biochemistry and microbiologists are taking painful efforts for this. In this context, inputs from today's resource persons are also highly solicited. Today's all eminent speaker personalities are known and national and international corridor. Carlos is an authority on nanomaterials and wastewater management. Dr. Carlos has attended and presented many important papers in various international conferences. Today's eminent speakers have also agreed as one international conference after COVID-19 pandemic. I am very much happy to welcome these personalities in this event. I hope their relationship with our college will further strengthen in future for the benefit of subject as well as students. I am very much happy to have such presentations, discussions on various subjects in this international e-conference, and it's a great occasion for web listeners and viewers also. Congratulate the organizing committee of this e-conference for giving such opportunity to students, teachers, thinkers, researchers, and participants. On this occasion, I assure that management will always support such activities in future also. Here, I would like to express my deep gratitude towards all the respected personalities who agreed for talk in e-conference in our college, which that is Karad, on the banks of holy Krishna and Koyna rivers. Before concluding my presidential address, on behalf of Sri Shivaji Education Society's Board for Higher Education, in the capacity of General Secretary of this institute, I once again welcome all dignitaries and participants in this international e-conference and wish you a grand success. Thank you.
Thank you, Bapu. Now I request Dr. B. Madik, Organizing Secretary, to introduce today's chief guest, Dr. B. Madik.
Today's chief guest and keynote speaker, Sir Dr. P.S. Patil. Dr. P.S. Patil, that is Dr. Professor Pramod Shankar Patil, is currently working as the head and professor in the Department of Physics and School of Nanoscience and Technology, Shivaji University, Kolhapur. Also, he is a former coordinator of Department of Technology and Energy Technology, Shivaji University, Kolhapur. He is the Dean of Science and Technology and DAD and Brain Pool Fellow. He is a recipient of Best Teacher Award in 2015. Professor Patil received his PhD degree from the Shivaji University, Kolhapur, India in 1990. He has been continuously engaged in the research field more than last 25 years. His research interest is in solar cells, gas sensors, nanotextiles, electrochromism, and supercapacitors. He has published more than 400 articles in well-reputed journals. He received more than 15,000 research citations for his research articles with H index 63. Thank you.
Thank you, sir. Now I request Professor P.S. Patil, sir, to deliver keynote address.
Okay. Very, very good morning to all of you. The president of today's function, Honorable Sri Prakash Ji Bapu Patil Sahib, Honorable Honorable Goffene sir, eminent resource persons, Dr. Luciane Carlos from Argentina, and Dr. Sushil Kumar Jadhav from School of Nanoscience and Technology, Shivaji University, Kolhapur. Convener of this conference, Dr. Poddar and Dr. Gurungle, all the faculty members of this college and the faculty members who are attending this conference virtually, and my dear participant student friends. I am indeed very happy to be here on the occasion of inaugural function of this international e-conference on chemistry research and competencies organized by Yashwantrao Chavan College of Science, Karad. I am indeed very happy to learn that This college was established in the year 1958. That means 4 years before the establishment of Shivaji University, Kolhapur. This indicates the dream and the vision of Honorable Shri Yashwantrao Chavan and his colleagues. This is very important to see that this particular college is enriching the knowledge of the students and the faculty and enriching the society in and around Karar city. It is emerging as one of the important and eminent college of Shivaji University, Kolhapur. There are about 293 affiliated colleges in Shivaji University, Kolhapur, and Yashwantrao Chavan College of Science, Karar, has made a special mark on the history of Shivaji University, Kolhapur. Here, but in this particular conference, it is on chemistry research and competencies. But I am a man of physics, working in the field of material science with the vision and mission of nanoscience and technology. I am working in these fields, physics, material science, and nanomaterials, and nanoscience and technology for the past 30 years. However, the role of chemistry has played a very important role in my research. Because it is a material science, the role of chemistry is very, very vital, very important. Without chemistry, we cannot lead to a significant discoveries in the material science, nanomaterials, and nanotechnology. And therefore, I'm very, very happy to address to the gatherings of this particular international conference on research, chemistry research, and competencies. I'm doing research in the field of smart windows, electrochromism, then third generation solar cells, then sensors, supercapacitors, batteries, nanotextiles, and different nanomaterials synthesis and characterizations. For the last 30 years, I've been confronting with the chemistry, and therefore the chemistry and physics should always go hand in hand, in my opinion. So I did the first attempt on Shivaji University to organize the international conference in the year 2008 by combining two departments on the campus, the combining Department of Physics and Department of Chemistry, and organize one international conference on material science, nanomaterials and science in the year 2008, that is 12 years back. And since then, I understood the importance of chemistry, chemistry research, and importance of chemistry competencies. The title is very, very important, and I was wondering what I should talk. I always talk about my research in various conferences, but since this is a chief guest address, I would like to stick up to the conference theme, which is very, very important. I would like to congratulate all the organizing committee members for this particular theme. This theme indicates two different areas. One is chemistry competencies, and second is chemistry research. How to build the chemistry competencies to have interactions with the industries by way of inculcating and empowering chemistry competencies. You can interact very well with the industry, and therefore this particular direction is very, very important. And if you want to mark your presence in the international and national map, then the chemistry research is very, very important. So from my perspectives, these two routes I am going to tell to the students. The first one I would like to highlight some more importantly is related to chemistry competencies, how the students and teacher and the college can grow with inculcating and imbibing the chemistry competencies. The competencies, I believe that it is like imbibing the skills, inculcating the skills into the students and teachers. So by way of inculcating the skills related to chemistry competencies, you can really grow and you can really do wonder in the field. Because, currently we are facing the problem of COVID-19 pandemic. And because of this pandemic outbreak, we are all in the lockdown mode. But however, you can learn many things by sitting at the home and coming out of the lockdown mode to the mission mode. I'm always thinking differently while sitting at the home, what I can tell differently to the students, what I can tell to the teachers, how I can tell them and convince them to think differently during this COVID-19. And this conference, chemistry competencies has come into because Dr. Sushil Kumar Jadhav sent me this leaflet, and I'm very happy to think something different related to chemistry competencies. In India, we very rarely focus on what is going on in the industry, what is going on in the society, what are the problems associated with the industry, what are the problems associated with the society, because we are so busy with our daily routines, like coming to the college, taking the lectures, attending different sessions of the practicals, going back to the home, doing homework, and therefore this particular tight schedule every day will bind you to the box of isolated domain of the bookish knowledge. But in order to come out of this bookish knowledge, you have to think differently. And this particular pandemic situation and this lockdown mode has given you an ample time to think differently and think out of box. You should come out of the knowledge which is written in the book and apply that knowledge to solve the problems of the society and solve the problems of the industry. And therefore, chemistry competencies is very important, and that may be the thrust area of your college. What I would like to tell you is if you look around the Karad or Satara or Sangli, Kolhapur and Satara districts, we are surrounded by a lot of industries. Do we conduct any industrial tours to the students? That is important. Do we expose our students to the industrial problems? Do we teach students with the industrial processes and teach them and show them and expose them and explore all these possibilities of the industries? I would like to give you some examples here. We are surrounded by the paper industry. I'm going to cover the industries which are related to the chemistry research and chemistry education. The paper industry, the students learn about the paper because it is a chemistry process, chemical processes. The paper industry, how to prepare paper bags, plates, napkins, and the trays, tissue papers, notebooks, and lamination, thermal papers, stationery. All these are the avenues which are open only under paper industry. Do we expose them to this industry? The second type is the plastic industry. Because if you look at the plastic industry, there are a lot of products available in and around our colleges, in and around our city. Like we always use the PVC pipes, air bubble sheets, injection molding products, woven bags, PVC wires, acrylic products, toys, PVC doors and windows, PVC bags, and so on and so forth. So this is entirely new knowledge that we are going to give to the students. This is very important. We teach polymer chemistry to the student. We teach organic and inorganic chemistry to the students. But do we teach how to prepare air bubble bags, plastic bags, or air bubble sheets? How to prepare PVC pipes? And this is very important knowledge, and that will in turn increase the chemistry competencies in the students. If I look at the polymer industry, which is coming up and which is flourishing like anything, and in the polymer industries, you can learn how to make detergent powder, how to make soaps, how to use and how to prepare and synthesize your own toilet cleaners, adhesive tapes, shampoos, various types of shampoos, then lubricant, oil, then oil paints, manufacturing, rubber manufacturing, bleaching powder. Because yesterday I was cleaning my bathroom and I was using a Harpic, which has a bleaching. Harpic bleaching is a new product that Harpic has launched. And I was wondering how this Harpic is used to bleach the tiles in the bathroom. So this is nothing but the chemistry. And these are the products which are vital and which we use in day-to-day life basis. Do we arrange any practicals related to how to make all these products in the college laboratory? do we give them some project, some minor projects, some major projects to the students? So project-based learning in the colleges is also very, very important in order to build the chemistry competencies in the students. Another industry I would look into, because of the COVID-19, surgical and medical products that also requires knowledge of chemistry. Like hand sanitizer, everyone is nowadays using hand sanitizers and the soaps like Dettol, which kills bacteria and germs and even viruses. These hand sanitizers, if you just teach your student how to prepare a hand sanitizer, and if you try to market it, if you try to commercialize it, and the students will be Atmanirbhar, if he will stand independently, he will help your college to grow, your college economy will grow. We normally rely on only one source, that is the fees, collection of fees from the students. But have we ever thought of any resources other than the fees? The college can look into it and see this as an avenue. The pandemic situation has taught us a lot of things, and therefore we need to learn it, from bottom of our hearts. So these surgical, like hand sanitizers, disposable plastic, even bandages, surgical adhesive tapes, mask, gloves, cotton buds, antibacterial liquids, anti-mosquitocidal liquids like goodnight mats, goodnight liquids, all this requires chemistry, because every night we use a goodnight liquidator, and it's what is that? It's a chemical solution. It evaporates, and it is very good for the expansion of the mosquitoes from the house, and thereby protecting us from the mosquitoes, and thereby protecting us from the diseases like malaria, dengue, and chikungunya. If we teach how to prepare this goodnight liquidator, it may not be goodnight liquidator, it may be some other brand name of your college, maybe, or any other brand name. It will come into the market in a much cheaper way. You can make a brand of your own college, and you can teach your students in that manner. There are some other industries which are important and related to chemistry, as I say, is bakery industry. There is a lot of chemistry in the bakery industry, how to preserve the products, how to make the cakes, how to optimize the processes. Everywhere, the role of chemistry is very, very vital. Not only that, there is a fast moving consumer goods like jewelries and soaps. You can also tell your students how to polish, how to make jewelry look more interesting, how to polish by way of metallizing, galvanizing, and anodizing or electrodeposition. And these are the processes that you can adopt to make jewelry look very, very attractive. There are several industries like related to food processing. There is a chemistry in the food processing and agri-food processing. Our region, especially Sangli, Kolhapur, and Satara districts, are surrounded by a lot of agricultural land. Almost 80% of the people are busy in the agriculture. They are farmers, and therefore you can grow and you can look agri-food processing as one of the important avenues and opportunities for the students to go there and learn from them and build some chemistry competencies related to agri-food processing. And for that, you need to know what is the problem available in the agri-food industry. What happens normally is understanding the problem itself is a problem to us. So for that purpose, in order to realize and understand the problem, you have to visit agri-food industry, any industry for that matter, and try to understand what exactly is the problem. And with your knowledge, can you solve that problem? There are other things like organic farming, hydroponic, aquaponic are coming up like anything. Hydroponic, aquaponic are the agricultural and plant. You can even grow exotic and medicinal plants using this particular hydroponic this thing. But this particular water that we are giving, less toxic it would be to the man, a human being. And there are some other industries like cement products, dairy products, even while sitting and traveling inside your city, you see a lot of wastages, a lot of garbages are there. And how to undertake waste management and recycling of the waste. Again, you can employ a very cost-effective, eco-friendly chemical processes for the waste management and waste recycling. Can our student help our society in eradicating the problem of the waste, which is dispersed everywhere inside the city? Can we do that? Can we have a master plan for that particular thing? Then the real sense of college, that is the college for the society, will come into the picture, and we will really be able to help our society. There are maybe electronic and electrical equipment industries, textile industries everywhere, because we are very close to the Ichalkaranji, which is the Manchester of India. Manchester of the India, they have a lot of apparel industry. They have textile industry. They are using different dyes, and they are using ample amount of chemical processes in there. Have we exposed our students with those processes by which you can treat our textiles, we can treat our fabrics? Fortunately, we are doing some work in related to fabrics and textiles. We are growing nano textile and nano fabrics. This is first time in India that we are trying. First time in India we have tried nano khadi, because khadi is the trademark of India. Khadi is the gift of Honorable Mahatma Ji Gandhi. So, Father of the Nation has given us this particular gift. Can we impart some functionality to that particular khadi by embedding and submerging nanoparticles into the khadi, so that the khadi will become antibacterial and it will become antiviral product, anti-germ product? Thereby, your khadi shirt and khadi dress will protect you from viruses and bacteria. So this is very, very important. Recently, we have adopted a very novel chemistry and came out with a very innovative product, first time in India, which is called as a fabric spray, which is called as a virus kavach. If you spray that particular kavach and solution on your fabric, it will protect you from virus called as COVID virus EVA. We have tested it and verified it. So these particular ideas will give birth to new industry and new avenues. So chemistry competencies are very, very important. Not only that, the list is endless. If you ask your students to look into the industries related to the forest-based products like coir and other products like bamboos and other things, there are many products which are coming to us from China. Can we replace all these products with the bamboo by eradicating the plastic? Can you give some small projects to your students? And all these things are really very, very important in order to build a good competencies in the students. In fact, in my opinion, every college is like arts, commerce, and science college, but the college should be recognized from the basis of the skill that we impart to the student, on the basis of the competencies that we impart to the students. There are 293 colleges in the university, but can we really earmark some of the colleges like your Yeshwantrao Chavan College as a college with competencies in polymer industries? Can we do that? Can we develop the skills in our students? So entire theme of your college may be diverted and directed towards the polymer industry and polymer chemistry. Or this is just for example I'm giving you. So tomorrow, every college will be recognized not only as arts, commerce, science college, not only an arts, science and commerce college, but it will be recognized as a hub of chemistry industry, hub for the polymer industry, hub for organic farming, a college as a hub for agricultural food processing. So can we do this? Can we impart new identity to the colleges which are affiliated to Shivaji University? So in fact, in every college, we have to promote such activities for the betterment of the stakeholders of the colleges. Maybe depending on the local need, what is the local need of your, this thing is very, very important. Location specific problems, can we solve that particular problem? And because of that, I'm going to launch a very innovative idea, which is called as a college, knowledge, and village. the new idea like college, knowledge, and village. College will develop the knowledge bank, and that knowledge bank will be beneficial for the villagers. That means villagers means the society. So very aim of establishment of the college, very aim of establishment of the universities in India is that the college and university should create knowledge for the betterment of the society. If our knowledge, if our research is useful to the society, it will help nation building. And therefore, this particular important aspect that we should focus more on that. How to make this college a better place for the chemistry competencies? That is the real question. Probably the eminent speakers like Carlos and Dr. Sushil Kumar will guide you on these particular aspects. In my opinion, every college should be the powerhouse of ideas. Every college should be the powerhouse of skilled manpower. What it requires for the industries to grow, it requires a very ample space, it requires some laboratory equipment, and it requires people, space, lab, lab, and human power. That is all there in your college. So why not you start some industrial project? Why not you start some mini industry in your college? Is it possible? You can build a team and you can enhance the capacity of the team so that college can start some minor industry. At least nowadays in the new education policy, as well as our central government and state government, we are stressing a lot on building up startups, to start the entrepreneurship so that the students will be independent after taking the degrees, after taking the bachelor's degrees, after taking the master's degrees. But if we try to, and if we are successful in imparting these skills, the students will not only be the master in science, but they will be the masterpiece in science. We want to convert each master degree students into masterpiece, and that can be done by imparting chemistry competencies in the students. And therefore, I think this particular theme of organizing the international conference is very, very important. Please look into that very, very seriously after this conference. If you need my help, if you need a help from Dr. Sushil Kumar, we are always there to help our college. The second theme I'm going to come, because it's a very, very huge theme. The second theme of this is chemistry research. How to make your deeper mark in the international landscape of research is very, very important and very, very serious task. For that, of course, if you really do that, if you really accomplish this task, you can lead to the IPR, intellectual property rights. You can file a lot of patents. So how many patents you have generated from the college is very, very important. For the patent, you need ideas, and we know the power of ideas. One idea can change entire nation. Like Mark Zuckerberg has an idea of launching the Facebook. That particular idea has changed the world. So we need to teach our students how to generate ideas, how to come up with the ideas, and these particular habit of making ideas clear will be imbibed into the students through high quality research in chemistry. Research in chemistry has endless opportunities. Since I am working in the field of solar cells, I am using daily chemistry because nowadays I am focusing on a material which is called as a perovskite material. The perovskite material cannot be prepared, it cannot be synthesized, it cannot be optimized, it cannot be calibrated without the knowledge of chemistry. A lot of chemistry is involved, and a lot of people, a lot of scientists across the world are coming up with a wonderful, wonderful, interesting ideas of perovskite materials. We have developed three-dimensional materials, as well as we have already seen that some of the disadvantages are there in 3D perovskite material, and that is the stability. And we are proposing how to improve the stability of these three-dimensional perovskite materials, which is normally called as a methyl ammonium lead iodide. It is again all chemistry. So this chemistry-based research is very, very important, and we are improving the stability, environmental stability of these perovskite materials by growing two-dimensional perovskite materials, which is called as a Rudolfson proper perovskite materials, and Jacobson Diane perovskite materials. And these are these perovskites which can be grown in the fashion of two-dimensional materials, and thereby you can minimize the surfaces which are exposing to the air, and thereby you can reducing their vulnerability to the air and atmosphere. Thereby you can increase the stability. I think many more things will be narrated by eminent speakers, and therefore I will not take too much time. I think I have already taken half an hour. So with this, my brief remarks and presidential address, I would like to start. Before start, I would like to congratulate all the organizers of this particular conference, the principal organizing secretary, and Prakash Bapuji Patil Sahib, who has given the idea of organizing this international e-conference on this chemistry conference, chemistry competencies and chemistry research. Thank you very much, and I wish you all the best for the entire sessions. Thank you so much.
Thank you, sir, giving a very nice information. And now I request, now sir, lecture is over. Any questions from participants? Please put your questions in a chat box. Sir, sir, one question is from Linesh Pawar, Maharashtra. She asked,
Okay.
95 masks are not suitable for prevent the corona.
Okay. What is the question?
He asked, the 95 mask, N95 masks are suitable for prevent the corona or not?
N95 mask
Yes, yes,
are suitable to avoid the corona or not?
yes, yes.
N95 masks are supposed to be used by the medical doctors and other staff members who are working in the COVID-19 hospitals. And I think this N95 mask, which are in true sense N95 masks, will avoid and will deactivate the viruses, in my opinion. Yes, it is possible.
Okay, 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 sir. Thank you, sir. Okay, any other questions from? Okay, sir. Thank you, sir. Thank you very nice, sir.
Thank you very
Now I
much.
request,
Thank you.
okay, okay, sir. Now I request Dr. UP Lad to introduce our speakers. Dr. UP Lad.
Yes, I am Dr. UP Lad, member of organizing committee of International E-Conference on Chemistry Research and Competencies. My pleasure is to welcome our guest of honor and speaker, Dr. Luciano Carlos, who was born in Neuquén, the provincial capital bordered by Andes Mountains, Colorado River, Lime River. Neuquén is situated in world's 8th largest country of South America, known as Argentina. I would like to tell you little bit about him before he starts his core speech. One indicator of the range of Dr. Carlos' knowledge and expertise is the fact that he is currently member of research career of National Scientific and Research Council, Government of Argentina. He is independent researcher scientist at the Institute of Research and Development in Process Engineering, Neuquén, Argentina. He is also positioned as assistant professor for the subject of physical chemistry at National University of Cumahu, Argentina. Dr. Carlos has truly distinguished researcher himself as a magician to treat the wastewater. The hallmark of his research work is the degradation, oxidation, autocatalysis, photocatalysis, photosensitization, and one and the only creativity in adsorbing magnetic nanoparticles. Dr. Carlos has been recognized by Argentina Ambiental Award 2012 for his dedicated research work. Besides this, Dr. Carlos has also promoted by the heavy research grants time to time for his journey from doctoral studies to international project scientist. Dr. Carlos is the first researcher director who writes on development of magnetic flocculants for water treatment. His brain still has mysterious ideas about to protect water, to protect life, and to protect earth, which is still unfold mystery towards world. Now, again, I would like to welcome him, and so you can hear what he has to say. Thank you.
Thank you, Lord sir. Now, before the starting lecture, I request all the participants keep any question related with this session. Please share your or send your questions in the chat box with your names and address. Now I request Dr. Luciano Carlis to deliver lecture.
Okay, good morning for all of you. Thanks for this kind presentation. And I will start with my conference. I need to share the screen first.
Sir.
I have the permission to share the screen. Yes. Okay. First of all, I would like to thank Sushil Kumar Hadaf and the organizing committee and the Shihab University as well for inviting me to deliver this talk. It is a pleasure for me to participate in this conference. So this morning, I will address the subject of magnetic nanomaterials, the use of magnetic nanomaterials as nanoabsorbents for pollutant removals. These presentations will be divided in 4 sections. First, I will give a brief introduction related to the nanomaterial and absorption processes. Then I will talk about magnetic nanomaterials and their properties. Then I will introduce the most widely used nanoabsorbents and their applications to remove pollutants. And finally, a conclusion and future perspective will be given. Okay, here I show you some simple definition because we are talking about nanomaterials. So here I show you the definition of nanoscience, nanotechnology, and nanomaterials. You can read them on the slide. And I would like to highlight the definition of nanomaterials. I've taken this definition from the ISO standard methods. This is the important thing that we should have at least one external dimension in the nanoscale. When we are talking about nanomaterial, this is what we have to take in mind. So when we set size nanoscale range, we are talking about size range of 1 to 100 nanometers. And also, if we want to define the nanoparticles, we need at least 2 external dimensions in the nanoscale range. And when we use nanoparticle as absorbent, what are the advantages? Okay, the most important features of nanomaterials are the high surface area. This is a very big issue because we have a very high surface area, around 102,000 square meters per grams. And another important feature is that we can obtain a low-cost production method with adequate synthesis, for example, and also these nanoparticles are very effective to remove contaminant even at low concentration. This is a very important feature of these nanoparticles as well. And another interesting point is the less waste generation. This is also important when we look the environmental impact of the process. And also the nanoparticles have some interesting magnetic characteristics such as superparamagnetisms. I will show you, I will tell you some important features of magnetic properties below. Then I would like to speak about absorption. All of you, I suppose, know the absorption processes, but I would like to highlight the 4 key steps of the absorption process. And the first one, the pollutant absorption. This is very important and is related to the design of the absorbent. In this point, we have to keep in mind that we need an absorbent with a high affinity to the pollutants that we want to remove. So this step is related to the design. The second step is related to the recovery of the absorbent for further use. This point is very important because when we manipulate or we use absorbing, we want to use more than one cycle. So the separation processes, it's very important, and a normal separation processes is done by centrifugation or by filtration, and these processes are not cost-effective processes and have problems when we handle large volumes of water. So, and in this point, the magnetic separation has emerged as a new technology and could resolve problems related with the cost-effective treatments. And here, this is because we use magnetic nanoparticles, because the magnetic nanoparticles can be manipulated or separated with a magnetic separation processes. Then in the third step, we have the absorbent regeneration. This is also very important because we want to reutilize this absorbent. So we have to design the processes to regenerate the absorbent. And finally, the fourth step is the management of both regeneration solution and the saturated absorbents. Here I show you a simple scheme of the absorption with the magnetic nanoabsorbent, only to show you how we can perform these magnetic separation processes. Here, the first step, I don't know if I can rule. Can you see the red spot on the slide? So here we have the magnetic nanoabsorbent. We put in contact with the polluted water, then the absorption process takes place. We have here the pollutant absorbed on the surface of the absorbent, and we have to perform the separation of the supernatant of the aqueous solution from the nanoabsorbent. So we perform a magnetic separation processes. Then if we can separate this water, we have the polluted water. And to continue with the cycle, we must regenerate the nanoabsorbent particles. There are different steps, different physical or chemical procedures to regenerate the nanoparticles. And then if we can separate the aqueous solution from the nanoparticles, these clean nanoparticles can be reused in a next cycle of absorption. This is this simple cycle of the way we can use this magnetic process. Here is simple literature reports that I found in Scopus. In these figures, I plot the number of publications against the years, and as can you see here, I did this research this search in the literature using these keywords. First, I use magnetic nanoparticles, absorption, and heavy metals, and we have these bars. And then I did another search with this keyword, magnetic nanoparticle, absorption, and organic pollutant. In order to see the difference, if we have more research papers related to heavy metal removal or organic pollutant, and as can you see here, are more or less the same. But the interesting things from this figure, it's the use of magnetic nanoparticles to remove pollutants. It started in 2000, 2002, more or less. And then we have an exponential growth of the research papers on this topic. And we have more than 4,000 published research papers in 2019. So this means that this is a very hot topic in the research field, that there are many research groups around the world working in that subject. So what are magnetic nanomaterials? Here I leave you a simple definition, but very effective. Magnetic nanoparticles. Magnetic nanoparticles are a class of nanoparticles that can be manipulated using a magnetic field. And commonly, we have iron, nickel, and cobalt, and their compounds like ferrites as magnetic elements. This is very simple. Here, I don't want to deepen in the magnetic properties, but here I show you a table that summarizes the main relevant form of magnetism and their features. And as can you see here, ferromagnetism has susceptibility larger, a high susceptibility, and also ferrimagnetism. So ferromagnetic material and ferrimagnetisms are elements or material that present this magnetic form are those in the preparation of magnetic nanomaterial for wastewater treatment. Why? Because the other form of magnetisms have very low susceptibility. So if we want to manipulate a material with an external magnetic field, we need high susceptibility. So these two magnetism forms are the material that we want to use as absorbers. And the commonly magnetic carriers that we use in environmental applications are magnetite and maghemite. I mentioned before that we can use iron, nickel, and cobalt, but iron species or iron oxide are more used because iron is more abundant in nature and also is not toxic. Nickel and cobalt has, at certain levels, are harmful to human body and ecosystem. So it's preferred to use iron oxide nanoparticles instead of cobalt or nickel oxides. And here I show you the structure, the crystalline structure of both iron oxides, and magnetite and maghemite has the inverse spinel structures, where magnetite has the tetrahedral sites occupied by iron 3, while the octahedral sites are occupied by iron 3 and iron 2. Instead, in the case of maghemite, they have the same spinel structure, but the octahedral sites are occupied only by iron 3. So it can be assumed that it's a ferrous-deficient magnetite isometric crystalline form. So maghemite can be formed from the oxidation of magnetite. This is a very easy way to obtain maghemite, for example. And also there are interesting, important magnetic features when we deal with nanoparticles. Here in this figure, I show you the magnetization curve of a ferromagnetic material. This is the common magnetization curve that we can obtain from this figure 3 magnetic parameters in order to characterize the magnetic properties of a material. And one of them is the magnetization saturation is the highest values of magnetism that we can reach on a sample. Then we have this point that is called remanence, and it's a measure of the remaining magnetization when the driving field is dropped to 0. And then we have another parameters here. This coercivity is a measure of the rubber fields needed to drive the magnetization to 0 after being saturated. But when we deal with nanoparticles, for example, this graph could be for magnetite, and when we use magnetite with size lower than 30 nanometers, we can obtain this typical curve. And this curve is typical from it's called a super paramagnetic material. And why? Because we have almost 0 coercivity and remanence. And these kind of magnetic materials are better for use as absorbent because are easily manipulated and are easily used in the magnetic separation processes. Here, a nice picture of how is the relation with the coercivity with the particle size. And here we can see that when the particle size is very low, in case of magnetite, lower than 30 nanometers, this is the super paramagnetic region. But when we increase the particle size higher than 30 nanometers, for example, the coercivity started to increase and we enter the ferromagnetic region. This is a typical figure for magnetite or myamides. So another important surface properties of these iron oxide nanoparticles is that they have magnetite, for example, have a the 0.0 charge around 7, and this is the functional groups in the surface that we have. Bare magnetite nanoparticles are susceptible to air oxidation. This is an important feature. So they are easily aggregated in aqueous system. So if we want to use iron oxide nanoparticles as absorbents in a wastewater treatment, we must functionalize or cover this surface to avoid this oxidation and aggregation. And this can be done with different surface modification. And to finish with iron oxide properties, I show you here some methods to prepare these iron oxide nanoparticles. Only I put in the slide 4 methods because this is the most commonly method used for preparation magnetic iron oxide nanoparticles for environmental application. There are more than these 4 methods, but this is the most used. And within these 4 methods, the co-precipitation method is the simple and the most efficient chemical pathway to obtain magnetic particles. So if we want to prepare also a nanoabsorbent, this method could be the best method. Why? Because we can obtain the highest amount of nanoparticles there are to produce nanoparticles with this method. We don't need higher temperatures, more than 100 degrees, for example, and we can avoid the use of organic solvents. So for this reason, this method is very appropriate for preparation of absorbent. Okay, now with magnetic nanoabsorbents. I mentioned before that we have to cover this iron oxide surface because it could be oxidized and is easily aggregated, and there are these 2 points. If this material are oxidized, we can lose these magnetic properties. So in order to get more efficient properties as absorbent, more affinity to pollutant, and increase the absorption capacity, these iron oxide nanoparticles are covered with different kind of material. And here I divided this material in 4 sections. Silica, activated carbon or carbon-based materials, clay minerals, and natural polymer unwasted. And in the next slide, I will talk about this kind of nanomagnetic absorbers. Here we can start with the silica-based materials. I put a picture of the different morphology of magnetic nanoparticles. This is, I choose silica mesoporous because mesoporous silica are most widely used materials compared with amorphous silica, because the surface area are very, very higher than amorphous silica. So this kind of material are more used than the amorphous one. We have different strategies to develop this composite of magnetic silica mesoporous nanoparticles. And here, for example, we have mesoporous silica spheres embedding monodisperse magnetic nanocrystal. This is these black dots on the slide. Then we can perform also a core shell nanoparticles like microspheres encapsulated magnetic cores into perpendicularly aligned mesoporous shells. This is the example of B here. Another form to prepare this magnetic silica mesoporous material is with ordinary mesoporous material loaded with magnetic nanoparticles inside the mesoporous channels. And the fourth one is prepare a rattle-type magnetic nanocomposite. This is the different kind of material that we can produce as nanoabsorbents, for example. And also, when we talk about silica particles, to increase this affinity and the absorption capacity, we need to modify or functionalize the surface of the silica. And this can be done with a commonly it's done with a silent molecule which contain different specific groups that have this specific affinity to certain pollutant. And here I show you some examples of different saline molecules that are commonly used to modify mesoporous silica. And the idea is to increase its absorption capacity. For this reason, we functionalize the silica surface. And in this table, I show you the application and the result of the application of these nanoparticles to remove organic pollutants. If you will get more details of this table, you can find it in this paper. This is a review article that we published this year. And only I want to result from this table that there are a lot of materials of mesoporous silica with different kind of functionalizations, and they function very well with organic pollutant. And I would like to highlight, for example, this kind of material, this SBA 15 is a typical mesoporous silica nanomaterial and have this very, very high absorption capacity to this dye. This is acid blue 25. And would like to highlight that. And also, excuse me, with this material, having my core shell magnetic nanoparticles functionalized with C18, and we have also very, very good results with removing methylene blue, for example. Then in case of clay-based composite, we can prepare this material in different ways. And here I show you a simple scheme of how to prepare this clay mineral magnetic composite. And for example, here the pathway A consists of magnetic pylarite clay minerals. If we want to prepare this magnetic clay mineral, one way could be first pilaring the clay mineral and to open the interlayer space to increase this space, and then this space could host magnetic nanoparticles. Or we can do, for example, the pilaring procedure with the magnetic nanoparticles directly. So we have two kinds of material. Also, we can perform a co-precipitation method where we have a dispersion of the magnetic nanoparticle on the surface on the clay mineral, or we can introduce the magnetic nanoparticles to the clay mineral through the intercalation methods, when we can use, for example, magnetic nanoparticles surrounded by surfactant that can be introduced inside the interlayer space of the clay mineral, for example. So this is very, very often used method. This clay mineral, this magnetic clay-based composite are very, very used to remove pollutant. And here I show you again a table with some result of the application of the clay-based composite. And we can obtain for clay composite, I show you a table with organic pollutant removal, but they have a better success with heavy metal removal. But in the literature, there are a lot of study with this kind of pollutants. I want to show you that always also this can be used with organic pollutants. And for example, we can obtain a very good result with magnetic montmorillonite, a clay mineral, and we can get more than 100 milligrams per gram of absorption capacity of methylene blue, for example. So again, if you want to see more detail of this kind of material, you can go through this paper. For the case of carbon-based composites, there are many carbon materials in the literature that have been used as a material to prepare magnetic carbon composite. And can you see here, I prepare a list of activated carbon with the structure: graphite carbon black, porous carbon, graphene oxide, carbon nanotube. These are materials that are being magnetized and also they are being used as absorbent to remove organic pollutants. There are many strategies to prepare this magnetic composite. Here a list of the different kind of methods to prepare this magnetic nanocomposite. And here I show you some 10 images of, for example, here this is an activated carbon black, activating carbon, sorry, with this magnetic nanoparticle dispersed in the matrix of the carbon. This is the black dot in this picture are the magnetic nanoparticles. And here, for example, a carbon nanotubes with embedded magnetic nanoparticles. This is another study that they could magnetize this carbon nanotube. And here, for example, show you this is a magnetic nanoparticle covered with a thin layer of carbon material. So this is also used as absorbent. Again, here a simple brief of the result that can be obtained when we use these carbon-based materials applied to remove organic pollutants. And here we can see better results comparing to clay mineral, for example, of the absorption capacity. There are, for example, very, very nice results by using these multi-walling carbon nanotubes with magnetite and functionalized with also a polymer. We have very nice results, more than 400 milligrams per gram in removal of methylene orange and Congo red dyes. And also here it's very, very interesting what was obtained with a graphene oxide sponge, magnetic graphene oxide sponge. This is the material, and we remove an emerging pollutant like tetracycline and the value of the absorption capacity that they obtain, the author obtained, is 473 milligrams per gram. And finally, the final material that I want to show you in this presentation are the natural polymer and wasted-based material. These are very important because the biopolymers or natural polymer are very cheap and they make a very cost-effective processes when they are used as an absorbent material, and we can result or highlight the chitosan or alignate as this kind of polymer. Here you can see the structure. The chitosan have amine and hydroxyl moieties groups, and alignate has carboxylate and hydroxyl groups. And this kind of group can serve to increase the affinity to absorb pollutant, for example. And also we can use wasted cellulose-based material to prepare this magnetic nanoabsorbent. And here a list of the different sources of cellulose-based material obtaining from waste processes. The most of them are from agriculture residues. So here you can see skin from different fruits and vegetables, remnants and branches and leaves. Also, you can see here coffee, silver skin wasted, beer, and it's a very nice result had been obtained with solid organic matter extracted for urban waste. Was a very nice work that we performed with the University of Turin. We prepare a magnetic absorbent using this kind of material. And here I want to show you a simple method to preparation this kind of nanoabsorbent. Here I show you the case study of this soluble extractor molecule from urban waste. This is the co-precipitation method, where very simple way when we mix iron 3 and iron 2 salts. We dissolve in aqueous system, then we heat until 90 degrees for 30 minutes. We add ammonium and the material, this absorbent material. And then after 30 minutes, we get these magnetic nanoparticles covered or with this material, this organic matter are covering the nanoparticles. So it's very easy and it's very simple to obtain this type of nanomaterial in this way. And here I show you 10 images of this material. Here you can see the iron oxide nanoparticles, more or less 10 nanometers, surrounded by the organic layer. And here as well, you can see the organic layer surrounding the magnetic nanoparticles. Here the particle size distribution we can obtain with the co-precipitation method, normally from 5 nanometers to 20 nanometers of size, more or less. And again, this is a table that I show you some result of this kind of material to remove organic pollutants. Here you can see the results of these SVO magnetic nanoparticles with crystal violet. We have a very, very good result, very high absorption capacity, and depending on the different kind of waste material, also we can have a very nice result. And this is very important because we want to encourage researchers to use waste material, because this lowers the cost of the process and also reduce the impact of the waste that we generate, because we are valorizing a waste given a technological application, for example. Okay, as conclusion of these talks, with these magnetic nanocomposites containing iron oxide nanoparticles are very attractive option to use as absorbent in wastewater treatment technology, doing this advantage. First, the synergistic combination of absorbent materials. We can say that we can put more than one absorbent material combined with the iron oxide nanoparticles, or we can improve the absorption capacity of iron oxide nanoparticle in combination with these absorbent material that we put on the surface of the nanoparticles. The use of the low-cost material, this is the very important feature because we can use wasted to prepare nanomaterials, the nanosorbent. The magnetic properties of this nanosorbent can facilitate the separation from the aqueous medium, reducing the overall cost of the processes because it's cost effective comparing than centrifugation and filtration. And we have the possibility of reuse the material many times. And also we have the versatility to apply in a wide range of contaminants. And I saw you in the different tables, you can they were different kind of organic pollutant with different properties like anionic, cationic, or hydrophobic or hydrophilic material. And finally, to finish this presentation, this is some future perspective of the application of this magnetic nanomaterial to wastewater treatment as absorbent. I would like to highlight that although there are many research papers that work with a magnetic nanomaterial, most of them are in a laboratory scale. And we need more studies to address the large-scale application. So this is a very important thing that we should or we must study in the future. So we need to study what happened with the stability, the regeneration, and the separation processes in large-scale application. Then also another issue, an important issue, is the efficient production of magnetic nanomaterials at large scales again. So this is very important because we have to consider the environmental impact of manufacturing these materials. The use of green synthesis routes is very important as well because they can reduce the overall production cost and help reducing the environmental impact. So we encourage the use of green synthesis to research groups that are working with this topic. And finally, I think that further study I need to address the likely fate of the nanoparticle discharge environment because we want to use this absorbent to remove organic pollutant, but it could be possible that this nanoparticle could fade or could finish in the environment. So the potential impact on the human health and the environment must be studied. Okay, thank you for participating and for your attention.
Thank you, sir. Now, topic is open for discussion. If you have participants have any question, please share their questions in a chat box. Sir, one question from one participant, Anuja, Women's College, Jharkhand, India. The question is, how much time is required to absorb the magnetic elements on magnetic nanomaterials?
Sir, can you repeat the question? I cannot understand you, sorry.
How much time is required to absorb the magnetic elements on magnetic nanoparticles?
Sorry, I can't understand you. Can you write also the question in the...
No, probably, if I can interfere, the question
Yes.
is about how much time is needed to absorb the pollutants on magnetic materials.
How dimension?
How much time is required?
How much time it is required to absorb the pollutants on magnetic material?
How amount is okay. it depends on the kind of pollutant, for example. And also it depends on the type of material. For example, when in materials like when you use polymers, natural polymers or waste, to remove more or less 10 or milligrams or pollutants, you need 500 milligrams or non-absorbent. So we have a relation more or less 100 to 1. This is for different materials, but it will depend on the kind of the pollutant we want to remove. For example, with a carbon-based material, the graphene oxide sponge is almost 1-to-1. They're in milligrams, so the absorption capacity is very high, but it will depend in the nature of the pollutant.
Okay, sir. Okay. Okay. Any other questions? Please send in chat box. Okay, sir. Okay. Thank you, sir. Thank you very much, sir, for giving a very nice lecture, sir.
Okay, thank you. Okay. Thank you all of you for this kindly invitation.
Okay, sir. Thank you. Okay, sir. Now I request R.S. Patil, sir, to introduce our next speaker. Patil, sir. Okay, sir. Okay, sir. Patil, sir, please unmute.
Welcome you all in International E-Conference on Chemistry, Research and Competencies organized by IQAC and Department of Chemistry, Yeshwantrao Chavan College of Science, Karad, India. Good afternoon, you all. Today we have with us Dr. Sushil Kumar Jadhav, Assistant Professor, Nanoscience and Nanotechnology, Shivaji University, Kolhapur, Maharashtra, India. He has obtained his MSc degree from Shivaji University, Kolhapur, Maharashtra, India. After MSc, he worked as a research project assistant in CSIR's India's National Chemical Laboratory, NCL, Pune. He obtained his PhD degree from University of Genova, Italy, and he has 8-year experience of extended postdoctorate at University of Pavia and University of Torino, Italy. He has published 51 research papers in peer-reviewed international journal and authored 48 conferences communications. He leads polymer and hybrid nanomaterial research group at Shivaji University, Kolhapur. With this brief introduction, I hand over the session to Dr. Mahisa. Thank you.
Okay, thank you, Patil, sir. Now I request Dr. Sushil Kumar Jadhav to deliver the lecture.
Hello. Hello. Can you listen me loud and clear?
Hi. Hi. Yes, sir. Yes.
Yes, sir.
No
Yes, sir.
problem.
Okay. Thank you very much. Thank you very much, my sir. I would like to begin my speech by thanking the organizers of this conference, and in particular, Principal Kedar sir, Convener Burgle sir, other members of the organizing committee for putting up such a nice event online for the participants. Nowadays, there are many web conferences or e-conferences or webinars are going on. And when I received the invitation to speak in this particular international e-conference, I thought of a subject that can be useful for young researchers, irrespective of their subjects. That is, even if a chemistry, physics, biology, or any other science subject, a student, especially a researcher, joins this particular e-conference, he will be benefited by listening to the topic which is of importance, especially to the budding researchers, such as young PhD in their first or second, where they would like to learn how to write a good research paper. Nowadays, colleges, university departments are giving increased importance to research, and therefore they expect their students to not only do research but also to write good research papers. So I begin the talk with a philosophical thing, that is qualities of a good researcher. So what are the qualities of a good researcher? So these are listed in the circles here. So a good researcher should have research skills, laboratory skills, interpretation skills, communication skills, and interpersonal skills. The topic of which I am going to talk about today comes into the category of communication skills, where you are expected to speak well and write well. For example, to write an effective, good research paper. Now, as a student, I always tell to my students, in fact, as a guide, I tell to my students that try to develop all these competencies in order to be a full-fledged all-around researcher. Now, what exactly is a journal? Journal is a science magazine that publishes a paper. Instead of paper, as written on the slide, is a method to communicate your research to the scientific community or to the readers of the journal. Now, there are different motivations to publish, because whenever you are doing research and want to publish papers, there should be a motivation to publish the papers, and this motivation varies from person to person. Well, 54% of the people who want to publish papers, they want to publish papers for dissemination of the knowledge. So dissemination in simple terms means spreading of the knowledge. 20% would like to publish papers for career prospects in order to obtain promotions, for example. 30% of the people would like to publish papers for improved funding. There is also an interesting factor called as ego. So 9% of people would like to publish papers for egoistic purposes. This may happen because of the competition. Everybody would like to have more number of papers. So ego is there. Patent protection, of course, some important inventions can be protected through intellectual property rights. And there are some other motivations to publish papers. Now, there are two perspectives in order to look at the papers, the author behavior and the reader behavior. As an author, you want to publish more, you want to publish more papers. You think that whatever paper you publish, the journal should be peer reviewed, that is international peer reviewed journal. Then some other journal factors are also crucial, such as the factor readership of the journal, quality of the journal, whether it's a national journal, international journal, etc. And you expect as an author, there should be wider dissemination of the results that you publish in a particular journal. As far as reader behavior is concerned, they want to read less. So as an author, you want to publish more, but readers want to read less and obtain maximum information in minimum words. They want integrated system. They want free access to all the papers so that they can carry out their research without, putting money on accessing the information or the citations or the papers. And of course, they want quality information. So these things go hand in hand, and one has to consider both things while writing a paper. Now, how to begin to write a paper? First step is getting ready with your data. Then prepare the first draft, that is arranging things to be ready to start writing the paper. Then you have to understand what exactly is the structure of a scientific paper. Then you have to select the journal to submit the paper, and you have to also know what exactly is the submission process or the publication process. So we'll go on looking at these points one by one. And first thing, when you think of writing a paper, is to get ready with your data, and that data is normally present in your lab book. And that's why I keep on my students telling that your lab book should be always complete and with all the details in order to, be ready to prepare the first draft of your paper. Now, before you begin, you can also prepare all the figures and graphs in the required format of the target journal and keep them ready with you. Now, you can discuss the data with your advisor in order to improve it or improve the representation. The second step, the third, in fact, to understand the exact structure of a full scientific paper. Now, everything begins with the title, as many of you are referring many research papers for your works. You are well aware with the structure of a scientific paper. So the structure of a full paper starts with the title, followed by abstract keywords, table of content graphics, introduction section, experimental results and discussion, conclusions, acknowledgements and references, where list of citations is presented, and some appendices such as supporting informations. So we are going to see one by one that how you have to write things in these different subsections of a paper. Now, here on the slide is a list of the subsections and what exactly you have to write in those sections. Now, as far as the title is concerned, it should clearly describe the study. Authors is the list of persons who carried out the research. Abstract describes what is done briefly. Keywords ensure correct abstracting and indexing of your paper. Introduction explains the research problem. Methods explain how the data were collected. Results and discussion section present what data you have obtained and how do you interpret it, and discuss the implications of the findings. And acknowledgements, of course, where you acknowledge funding to the research or help of persons to the things that you have presented. References, as I told, is the list of citations that you put up in your paper. Some journals have also appendices such as supplementary data. So whatever structure I have shown is a structure of a full scientific paper or a research article. Now remember that there are different type of research paper. So a full article is a type of research paper. Then some other type of research papers are communications, letters, short papers, etc. Now, not necessarily the papers published in those formats like communications, letters have the whole structure of the paper that is shown on the left hand side of the screen. But it may contain the same structure in a hidden format or in a abbreviated format, so in a short format. So you have to understand the structure of a paper and what things should be written in those sections of the paper. Now there are some journals which publish papers which are specialized in a particular type of article. Like for example, some journals publish only reviews. The example is chemical reviews or chemical society reviews. These two journals publish only reviews. Communications, so chemical communication is a very famous journal, chemistry, that publish only communications. Some journals publish only letters such as material letters, and some journals publish full length articles. So first you have to classify your own paper that in which category it comes. So let's begin with the components of a good research paper. So the title, title should be brief. Use active verbs in the title. Keep the title length to 10 to 12 words and use keywords in the title, and that increases the hits on Google and various search engines on your paper and increases the possibility of readership of your paper. Uh, Here are two examples of titles, that how the titles of a paper should be. You can see at the bottom of the screen there are two titles shown in bold fonts. The first title in fact is extended, contains more words, and also it contains abbreviation or acronym that is not understood by all of the scientific community. So you have to avoid such abbreviations and acronyms which are not widely uh, understood by people. So instead, in the second example, you have a title which is much brief and where point to point information is presented about the contents of that particular paper. Now, as far as abstract is concerned, abstract is like your window to the article. So it's like a showcase of your paper. So if you put good and impressive things in the showcase, then only you can attract the readers and they will download and read the full paper, and most likely they will cite your paper. So abstract basically is a brief summary of the work, and that includes in a short way what has been done in the paper and what are the main results of the work. Uh, Remember that together with the title, the abstract should stand on their own. So many times there is a possibility that readers will read only abstract of your paper and not the full paper. So abstract should stand of its own and it should clearly state what is done in that particular research, in the study, and what are the main outcomes. A good thing to write the abstract is at the end of the paper. That is when you uh, first finish to write the paper, then you write the abstract at the end. And you have to refer to specific general guidelines to prepare the abstract. Now remember that literature search engines such as Scopus, CAS, SciFinder enlist only abstract of papers and of course the titles. So you have to be very careful while writing the abstract. It should be impressive. It should clearly state what has been done so that there is the possibility that the readers will download your paper, read it completely, and cite it. Here is just an example of an abstract from our own research paper. And what is advised while writing the abstract is that in the very first or second line, you point out the novelty of your work, and that catches the attraction of the reader, and there is the possibility that readers will read full paper beyond the abstract. So this is just an example where we have pointed out that uh, in the very first line, if you can see on the slide, that there is a word called as for the first time. And that particular phrase stresses the importance of the work, that what exactly is the novelty. Now, keywords vary, the number of keywords that are asked in a journal vary from journal to journal. Normally, 3 to 5 keywords are asked, and you should choose them smartly so that the keywords can also reflect what has been done in your paper. Some journals also ask table of content graphic and graphical abstract, and also a top entry text. You have to prepare these particular things by reading the guidelines of a specific journal. Now, top graphics and graphical abstract should be prepared in a smart way to attract the readers, and also they should represent the work in a graphical form. Some journals also ask highlights, and highlights are normally 85 word limit one liners, where you have to highlight the importance of the work in a very brief way. So these are some of the examples of highlights from our own paper, and you can see that highlights are chosen or written in such a way that they tell the readers the contents of the paper in a brief way, but also help the readers to understand what exactly is in the paper and what are the highlights of that particular research work. Coming to the main first section of the paper is the introduction. Introduction is the section where you have to clearly state the research problem. And if you can see the three boxes at the bottom of the slide, imagine a paper has a 3-paragraph introduction. In the very first paragraph, you have to start with the broad sense, in the sense, explain broadly the subject and area of your research and its importance. Then narrow down the explanation to your work or to the scientific domain in which you are working. And in the third paragraph, you have to highlight the importance of your work, that is, novelty of your work and the overall importance of your work to the scientific community in the domain in which you are working. So remember that writing paper is like storytelling. So you have to build up a story that is interesting for the readers, and you have to convey the results of your research in a logical, chronological manner. So state in the introduction that how your work differs from the published work, and briefly you can also describe experiment, hypothesis, research questions that are addressed in a brief way. Now, as far as the experimental part is concerned, experimental you always write in passive voice and never in active voice. So in experimental section, action or experiments that you have done are important and not the person who have done those actions or experiments. So remember, experimental is always written in a passive voice. So for example, um, you can avoid constructions such as I took 10 gram of sodium hydroxide. Instead, it should be written that 10 gram of sodium hydroxide were taken. So likewise, in a passive voice. So divide the sections into material, instruments, and methods, characterization, and synthesis. And in material section, you have to write down whatever chemicals that you have used for that particular experiment. Instruments, you have to specify the types and components of the instruments that you have used, and you have to also specify the methods, programs, scan rates, etc. that you have used, so that you have to provide enough experimental detail in the paper so that the same work can be replicated or can be reproduced by other researchers if needed. So experimental part is very important, and remember that you have not to hide any experimental details while writing paper. So experimental details should be given fully and with all detail. So the main core part of a research paper is the R&D section. We call it the results and discussion section, and where you have to present the findings of your research in the form of figures, tables, graphs, and some other impressive ways of presenting information. Now here you show your new results and how these results are contributing to the existing scientific knowledge. And you have to also follow a logical sequence of this information in the results and discussion section. So you can use the same logical sequence in which you have carried out the experimental work and explain the results and the findings of your research in a logical sequence in results and discussion section. Now, each figure should have brief description, that is legend, at the end of the figure, and it should be self-explanatory. Orders of figures should follow the discussion themes. So you have to follow or write your discussion in the order of figures. And in R&D section, the main important thing is not only the interpretation of the data that you have obtained, but you have to write how this data is new or different with compared to the things already published on relevant topics in the literature. So again, pointing out the novelty and putting up in front of the readers new results, new information, so that they can be benefited from your research. Here is just an example of a R&D text from our own paper, and it is important to highlight the new findings that contribute significantly to the field of research in which you are working. Now, if you look at the sample text at the bottom of the slide, Here, I can read out the sentence where we clearly state the importance, where we say that the technique that we have developed in our research can be uh, easily transferred to industry, and that highlights the industrial importance of the research that we have carried out. So we have to, be careful while writing results in this section, and we have to stress the exact scientific contribution that you have given to the field and write it in a proper way in the results and discussion section. Now, as far as conclusions are concerned, many times students confuse between conclusions and abstract. They think that the things written in abstract can be easily reproduced in the conclusion, but it is not the case. Conclusions are the overall conclusions that you draw from the series of experiments that you have done in order to prepare a paper. And they are, like a bit different than abstract section. Now, conclusions state what was the exact outcome of the study and indicate how the results relate the expectations and to the literature that has been previously cited or literature that is previously published. And many times it happens that you extend your conclusions beyond what has been proved in the scientific research in the paper. So you have to avoid that. You have to avoid undue speculations, and you stick to the conclusions of your own study only. Then at the bottom of the slide, there is an example of a conclusion section where we briefly have stated that how we have developed a new method to prepare beta cyclodistin grafted solid silica nanoparticles. And we have also stated in the very last sentence the general significance of the study in a broad sense, that how the, the information that is presented in the paper can be useful to the scientific community to produce preparation of beta cyclodextrin grafted nanoparticles. Acknowledgement section of the paper where you acknowledge various funding sources of the work, and also you can acknowledge the help of people that you helped you to carry out the experiments or to write the paper. References is a section where you cite all the previously published papers and put up a list of those citations at the end of your paper in the section called references. Here, only one suggestion is that you should avoid to cite unpublished results, or you should cite the papers which are published in standard journals, because whenever somebody is referring to the paper, he should be able to, also have access and get the citations or the references that you have cited in your paper. So they should be easily accessible and published in standard journals. Appendices include supporting information. This is a new concept that has been started since like 10 to 15 years, not more than that, where journals try to shrink the papers. They want to reduce the number of pages of a paper, and they want authors to present or put most of the subsidiary information in a file called as supporting information file. Now you have to refer to specific journal guidelines to prepare your supplementary information file. It's like a supplement of a newspaper where you provide experimental details, additional figures to the readers who are expert in that particular field and who want to know more details of your work. Now at the bottom of the screen, I have shown you in the screenshot that how you can access the supporting information of a published paper. So there is always a link near the title of the paper on the journal page, which takes you to the supporting information of that particular paper. And this supporting information is always available freely to all the readers. So even if your institute, university have no access to the journal or to the article, supporting information is always available. As far as the last part of the paper is concerned, there is always a list of citations in the form of references, and each journal use a different style of writing references. Now, as you can see in the example, I have shown one example from Australian Journal of Chemistry that how the references are cited. In the Next slide, I have shown an example that how the references are cited in another journal called as Asian Journal of Pharmaceutical Sciences. As you can see, the format of reference changes. So if you go here, they have used initials at the first. Instead, in the second example, they have used extended names. So how to deal with these references? So if each journal has a different way of putting up the list of references, there are some reference style management softwares or programs that you can use to arrange the list of references in your paper as per the requirement of any journal. So I have shown some very common reference management softwares which can be used for that purpose, and they are EndNote, then you have Redcube Papers, you have Mendeley, you have Zotero, and you have Citavi. Out of these 5 reference management softwares, in fact, you also have EndNote. It is embedded in the Microsoft Office. Out of these 4, 5, 6 reference management softwares or programs, the most common ones are Mendeley and Zotero. So you have to use these reference management softwares to arrange the references in your paper as per the requirements of the journal. These are freely available and easily downloadable programs. You can easily download them and they are very easy to use. So this is the anatomy of a scientific paper as it looks like. As I was telling in the introduction part, you begin the subject in a broad sense and then you narrow it down to the methods that you have used to carry out your research and the results you present to the readers. And from discussion to conclusion section, you again broaden the subject in order to highlight the importance of the findings in your research to the scientific community or to the scientific community working in the domain of research in which you are working. So, starting from a broad sense, bringing the readers to your specific methods and results, and then again broadening the scope and highlighting the importance of your work for the scientific community. So, we have completed the structure of scientific paper. Some other important things that you have to consider while writing a paper is first of that is English language. Remember that this is a problem of all non-native English speakers or writers. So very common comment of reviewers on the paper is about the English language and its improvement. So remember, there are 2 types of English that are British English and American English. There are some subtle differences in British and American English. For example, the spelling of the word color and color. Those who are working every day in the lab, they come across with this type of words and they know that there is a difference between these 2 spellings, and you have to use either the British English or American English and to be uniform throughout the document that you are preparing, whether it is a report, whether it is a presentation, whether it is a manuscript of a paper. Make sure you use one type of English throughout your paper and don't mix the things up. And this will also convince the editor of the journal when you submit your paper that you have taken care of the language that appears in your paper. Another important thing is to consider the plagiarism and related rules. Plagiarism is the wrongful appropriation and stealing and publication of another author's ideas or written text as it is and without their consent or without citing them. Now, plagiarism is considered as academic dishonesty and a breach of journalistic rules. So you have to be very, very careful. And my advice to all is that never copy and paste things in any paper that you are writing or any presentation or document you are making. If plagiarism is detected, your paper will be rejected immediately. So before subjecting to peer review process, normally editors are doing a plagiarism check of your manuscript, and if the plagiarism exceeds a certain limit, they will be rejecting your paper. Now, how much plagiarism is permitted in a paper. Now that depends on the journal. The rules vary from journal to journal, but you have to be very, very careful that there should not be considerable amount of plagiarism in paper. And whatever things you write should be of your own language, should be in your own language, and you write them properly. If plagiarism is detected after publication, the paper will be retracted. This may happen sometimes, and some legal action is also possible. So better things to avoid plagiarism. Now there are some plagiarism checker programs or search engines. Those are available, such as Grammarly. Then you have plagiarism checker X, Authentic, Urkund, and RightCheck. Now, Authenticate is one of the very famous, commonly used plagiarism checker. Most of the journals use Authenticate. Even in many universities, they use Authenticate to check the plagiarism of PhD thesis. As I was saying, while presenting the previous slides, the allowed plagiarism varies from journal to journal, and also the rules vary from university to university. As far as Shivaji University is concerned, the allowed plagiarism level in PhD thesis is 10%. Another important point from students or author point of view is the journal selection. Many times before writing a paper or after completion of writing a paper, the authors are confused that where should I submit my paper? Now, since last few years, main publishers such as Wiley, Elsewhere, Springer, etc., have started an online service which guides you to find a suitable journal for your paper. So the service is called a journal suggester or journal finder service. You can simply Google this term and you will be taken to the web page where you have to copy and paste the title and abstract of your paper, and the publisher itself gives you a list of relevant journals in which you can publish your paper. And not only that, that list also includes a lot of important data such as impact factor of the journal, readership of the journal, then average time taken for the decision or acceptance of the paper, etc. So this particular service started by all these common, very famous publishers help authors to find a suitable journal. Then, of course, comes important point of submission. Almost all of the journals nowadays have online submission systems. And while selecting the journal, you can take the help of a journal suggestion software, but also you can speak with your advisor. And with that, you can, select a proper journal that increases the readership of your paper. And that also gives you an idea about the target audience of the journal or target readers of the journals, and you can choose a proper journal. So here I show you the whole publication process. So when a paper is submitted, it is initially judged by an editor that is assigned by the system, and the editor decides immediate rejection of the paper based on the quality of the paper or whether the paper will be subjected to the peer review process. If he decides that paper is of suitable quality, then he invites reviewers and assign the paper to to the reviewers for reviewing. After that, the reviewers comment on the paper and they decide whether the paper is of good quality, can be revised further, it can be accepted as it is, or it can be rejected at the stage. Now, if a revision decision is taken by the editor on your paper, you have to properly revise the paper and resubmit the revised paper, and then it can be accepted based on the revision. Here are some emojis that show different levels of the publication process. Of course, if your paper is rejected immediately before subject to peer review, that is the worst thing that can happen to your submitted paper. If a revised decision is made on your paper, you can easily take into account the comments of the reviewers and address them systematically, and you can resubmit the paper and you can have the paper accepted for proper revision. you can, of course, sometimes it may happen your paper is rejected even after the peer review process based on the comments of the reviewers. If they are too negative, then the paper can be rejected. And it may also happen that your paper will be accepted immediately after submission based on the judgment of the assigned editor himself. And this is a rare case, but it may happen if your paper is of really good quality, if it presents cutting edge research, it presents a lot of novelty of work, and the results are of very much significance to the scientific society. So the paper can be accepted immediately after submission by the editor, or if you are a Nobel laureate, of course. Anyway, so some tips that how you can get your paper accepted for publishing or get it published. I can sum up this particular talk by showing you the do's and don'ts of writing an effective paper. So if you look at the screen, some of the things that I can sum up in this way, some do's are: explain the importance of your research topic, write in the introduction. Then talk about the main developments in your research area. Mention the missing links or gaps in your research that needs to be addressed. So this is to be an honest researcher. Highlight the main and relevant aspects of your study. Explain how your study will contribute to the development of scientific knowledge. This is very, very important. Organize your findings in a chronological order. Articulate your ideas in a clear and concise manner, and engage the readers by building a story. As I was telling in the beginning, that writing a paper is also like a storytelling. There should be a logical flow of the information right from the introduction to the conclusion section. You should engage the readers by writing the things in a proper order. Then there are some don'ts. So when you write a background that is too long introduction, for example, and they will start reading your paper. If you are ambiguous in your writing, that is also not good. You should not be disorganized. Okay. If you discuss unrelated themes, or you extend your imagination beyond what has been required to write, then that is also not good. Sometimes you elaborate too much on the literature instead of your results. So there should be a limit on the elaboration. Then sometimes you forget to provide a historical perspective. This happens sometimes. Some enthusiastic writers of a paper, they present the information as if they are the only one working on that particular field. So that is not the case. You have to acknowledge previous works done on that particular topic of research. And sometimes the authors, while submitting the paper, completely forget to check the requirements of the target journals. So what is important in order to submit a paper is to go on the website of the journal to which you want to submit your paper, download the author instructions pack and read it carefully, and prepare the whole draft of your paper right from the title to the supplementary information as per the requirements of the journal. And if you prepare your draft as per the requirements of the journal, the assigned editor will be convinced to submit your paper for peer review process. Okay, so with that, I almost come to the end of my presentation, and I would like to leave you to point out some of the literature that is available and some papers which are about writing a good paper. So the very first one is published by great George M. Whitesides that many of you may know. It published a paper in Advanced Materials about writing the paper. Then there are some other papers in the literature: how to write a scientific article and a guide to scientific writing. Most of these things are available in the literature. You can search them and download them. My message at the end of this presentation to all the participants is that remember that whenever you think of writing a paper or a report, or a patent or a thesis, remember that those who reads well writes well. So you have to be, reading a lot of literature, try to understand the constructions in those references, and if you understand that, you can write things well. Similarly, those who listen well and speak well. So whenever somebody is, giving you the knowledge through his lecture or seminar or presentation or teachers in the classroom, you have to listen them properly so that you can learn to speak properly in the future. So that is my takeaway home message from this particular lecture. And at the end, I would like to again thank organizers of the conference for giving me this opportunity to present a topic of interest for many young researchers. And I hope you have liked the information that I have presented. And I can say that my presentation is finished here and it is open for any discussion or question and answer. Thank you very much.
Thank you, sir. Now, topic is open for discussion. I request participant please send your questions in a chat box. Now, sir, Jadoo sir, one is question from Devendra Costa, Bhopal,
Yes.
MP. Question is, how much length is most superior for the international research paper?
Okay, this is a good question. So as I was telling during my presentation that the very important thing that you have to refer while writing a paper is the author information pack of the target journal. Normally, the limit of words, the limit of journal pages, and the limit of manuscript is clearly mentioned in that author information pack. That helps you to, prepare a paper of a suitable length that can be submitted to that particular journal.
Okay, sir. Thank you, sir. Sir, second question from Prakash from Pune, sir.
Yes.
How to avoid plagiarism, sir?
Okay.
Now, plagiarism is the most important thing.
Yes, good question. Good question. Many times, young students, also those who are working with me, my own students, they come with some difficulty that, oh, what should I write in this particular section? So they try to, reproduce some text which is already published. But remember that nowadays there are strict rules about plagiarism. So you have to build your own story and write things in your own words, and that guarantees that you avoid the plagiarism. Maybe like in 100 years, we will run short of sentences or words because all the sentences and words will be already used. So whatever you write will be considered as a plagiarism. But for now, you can avoid plagiarism by not reproducing the information that is already appears in some literature, not making copy and paste, and by revising your paper properly through some expert or by your guide.
Thank you, sir. Okay, sir. Thank you, sir. Thank you very much, nice sir, giving a very nice information. Okay, sir. Now I request G. Bedake, sir, for words of thanks.
Okay, thank you. Good afternoon. Myself, G.V. Dake, is here for expressing the vote of thanks. Firstly, on behalf of Department of Chemistry and Yashwantrao Chavan College of Science, I am thankful to Sri Prakash Pandurang Patil, General Secretary, Sri Shivaji Shikshan Sanstha, Board for Higher Education, for their presidential address. I would like to express the vote of thanks for our chief guest and keynote speaker, Dr. P.S. Patil, IQAC Coordinator, Dean, Faculty of Science and Technology, Head Department of Physics, Shivaji University Kolhapur, for telling us importance of chemistry in research. I am also thankful to Dr. Luciano Carrios, scientist at National University Argentina, for guiding us on magnetic nanomaterials and their use in wastewater management. Thank you, sir. I would like to express the vote of thanks to Dr. Sushil Kumar Jadhav, sir, Assistant Professor, School of Nanoscience and Technology, Shivaji University, Kolhapur, for guiding us on how to write the good research papers. Thank you, Jadhav, sir. I am also thankful to Principal Dr. S.B. Kengar, sir, for encouraging us for arranging this international conference. Thank you, sir. I am also thankful to Dr. S.H. Burungle, sir, Head Department of Chemistry and convener of this e-conference. Thank you, sir. I am also thankful to Dr. B.N. Gopne, sir, Coordinator YB Chavan Competitive Exam Center. I am also thankful to Dr. B. Madik, sir, for organizing secretary of this conference. I am also thankful to Dr. A.V. Mali, sir, for anchoring of this program. I am also thankful to Professor R.S. Patil, sir, and Dr. U.P. Lad, sir, for introducing our speakers. I am also thankful to Dr. J.U. Patil, sir, and Dr. Gigi Poddar, sir, for helping us and involving this program. I am also thankful to Computer Science Department for giving us cooperations. Last but not least, I am very thankful to all participants because without their presence, it is impossible for us to bring this conference to successful mode. Thank you all of us. Thank you.
Okay, so Mali sir. Okay,
sir, yes.
I just want to say two lines. First of all, I would like to thank my friend and ex-colleague Luciano Carlos for giving a nice presentation, and that too so early in the morning because it's like 3 or 4 o'clock in the morning in Argentina. So thank you, Luciano. Grazie mille. And I would like to thank organizers for organizing.
Thank you, Sushil, for this invitation. Don't worry about the time. It's very early for us in Argentina, but it was very nice to participate in this conference.
All of the participants liked a lot your lecture. I am full with the comments and feedback about your lecture. So you are like a second famous Argentinian in India now after Lionel Messi.
Yes, sir. Sure, sir.
Okay. So thank you. And thank you all the organizers. Okay.
Now feedback form, feedback link is given to the Telegram, WhatsApp, email, and WhatsApp groups. After the completion of your feedback, we will send you your e-certificates on your email. Okay, thank you, sir.